Alright guys, welcome back to the another video. In this video, I'm going to show you how to prepare this kind of landslide susceptibility map, which represent the which slope unit are more prone to fail and which are more stable. And in this particular video, I'm going to use fully open source software, which is QGIS, and then freely available dataset. And for this video, I'm going to use the methodology that was discussed in mapping susceptibility with open source tool or new QGIS plugin in QGIS by TTETAL. So let's get it started. All right, so here I prepared few of the steps. So I have only 4 steps that I'm going to use, and then using these steps, you are going to easily prepare your landslide susceptibility map within your area of interest. So first thing is about input dataset. Let me talk about the input dataset. So for this, I need admin unit, which will be useful just to download the DAM digital elevation model. And then another one is we need landslide inventories, or the landslide point where the landslide happened in past, right? And after that, we are going to install the plugin SZ plugin from that paper, and then we prepare the intermediate dataset, which is like one of the major dataset is slope unit. And after that, we will prepare the variable that might affect the landslide, for example slope, aspect, precipitation, and ANDVI. And after that, we compute the landslide susceptibility score using SZ plugin. So yeah, so first of all, let me load my input data set in QGIS. All right, so first of all, I'll load the OpenStreetMap here and then zoom into my area of interest. For today, I'm going to prepare the landslide susceptibility map in some region of Sri Lanka. So I'm zooming in here, and then here you can see my data set, which is input data set and intermediate output. I'm going to save some of the output over here, and then the final result in the final result folder. All right, so now let's load the input data set. So here I have, as I said before, I have admin unit. I'm simply going to load these, and then I have landslide inventory. Simply these are the like point representing the landslide location, and then the digital elevation model. Don't worry about it, I'll show you like how to prepare, how to get these data set. So let me first zoom into my admin unit. So this is my map, and let me put this down. So this is my study area, right? And then now I'll change this to the like simple field to maybe okay, outline, simple outline, and then maybe the color to red. Okay, so yeah, it will be easier for us to see the boundary of each admin unit. And then these point represent the point of landslide happened in past. And so let me go one by one. First of all, in order to download the study area, I mean the admin file, so simply you can refer to divagis.org. Don't worry about this, I'll provide the link in video description as well. So simply here you need to search whatever country you are interested in. For example, in case of Sri Lanka, so I need to select Sri Lanka, and then I'm interested in admin boundary. So simply click this link, and then it will download the this zip file. And using this zip file, you can feel free to select your area of interest, right? And for downloading the DAM, actually I already prepared that tutorial in my YouTube channel. So if you search for download DAM QGIS plugin GeoDev, so you'll land in this video or I'll provide the video link in the description below. So using this just 3-minute video, you can download the dam of any part of the world. It's SRTM dam, 30-meter resolution. It can be downloaded using Open Topography plugin over here. So I downloaded using Open Topography plugin somewhere here. Sorry, this one, Open Topography dam downloader. Using this plugin, feel free to watch that video if you like. And talking about the another one, for this landslide inventory, it might be a little bit tricky. So one of the easiest ways so far I found to create these landslide inventories is going to Google Earth Pro software. It's also free to install. And then simply go to your location. For example, I am interested in Sindhupalchok, which is one of the district in Nepal, and then try to find the landslide event, right? For example, this one, right? And then using this mark, just place the mark over landslide inventory, right? And then simply maybe this area also look like some landslide happened in past. So for example, this one is also landslide, right? Simply put your marker here, and then maybe you can write LS2 and then simply click OK. And now you can simply download this, save my place as, and then download it in KML file. And then you can load these files in the, sorry, looks like save place is okay. So here you can download this KMZ file or KML file, and then you can load these files into the QGIS and convert it to the shape file. So yeah, that's the easiest way. The other way is also this kind of data. Sometime like in the country level, in the country portal, they normally like update their database, and you might get freely from like government agencies. For this point also, I got this dataset from the one of the organization government agency in Sri Lanka. All right, so that's all about input dataset. So let's move to the other point, which is about installing the QGIS plugin. So for that, actually, so I have this like GitHub repo SZ plugin, right? And then here in the repo, don't worry about the link, I'll provide in the description. Here in the repo, actually, even though it's QGIS plugin, but it's unofficial QGIS plugin. That's why you need to download it manually. So there are 3 different download and install process. It's describing here. I'm going to follow the first, so which is about like adding the repository over here. So simply go to plugin, manage and install, and then in the setting you might need to toggle this on. So also experimental plugin, and then click here and then write SZ, and maybe you need to provide the URL, which is over here, and make sure this repository is temporary. They are saying this, so maybe providing this repository URL might not be the trusted way, but of course it's the easiest way. So I'll show you what is the other option we have in order to install this plugin. So after that, simply go to all and then search for SZ, and this is the plugin we are interested in, right? It's from TTETL, and then simply install it. Depending on your like PC processing power capacity, so it might take some time to install the plugin, because this library needs some of the like external third party packages is described over here in the requirement.txt. So scikit-learn, libpysal, and then Seaborn. You need these 3 packages in order to install this plugin. So basically in future this link might expire. In that case, and the easiest way I found is simply you need to download the GitHub repository as zip file. So simply download zip file from here, and then now you need to like upload that zip file to the okay, install from zip, right, to here, and then install the plugin, and it might pop up and then ask for the like installation of those three libraries. In that case, just install, and then it will simply install in your PC. So right now I already installed, so it's available over here. So after installing this plugin, you might see the SZ option over here too. So there are few options. Using these options, we are going to create the landslide susceptibility map. All right, so yeah, that's all about like installing SZ plugin. So let's move to the another topic, so which is about prepare intermediate dataset. The first thing we need to prepare is slope unit. Of course, we are going to use QGIS, and then in QGIS we have r.watershed function. This I believe this come with the grass GIS, and simply click it, and then select the dam is your elevation, and then this minimum size of exterior watershed basin. This is also hit and trial method to find optimum value of your basin size. So I set it 900 so that my basin will be not that small. So after that, you can increase the RAM as well if you like, but this is completely optional. So I'm increasing the RAM so that my processing won't take much time. And the thing is, we are not interested in any of these output except half basin. Just leave it as it is for the half basin. Open output file after running algorithm, but for other we can toggle off and then hit run. All right, so now my basin unit are created successfully. If you are unable to create this similar size of basin, then you might also need to check your QGIS version. Right now I'm using 3.40 version, 40 version. So I tried this in 3.32 version. It was not working somehow. So yeah, after that we simply need to convert this half basin to the vector. So for that, go to raster, conversion, and then polygonize, right, converting raster to vector, and then leave the band field name as it is, dn, and then save the vectorized file over here inside intermediate output. So for now I'm overriding this, so rated that output, but anyway I'm going to run it. All right, so this is the vector representation of this half basin, and then if you want, you can do the you can change the simple fill to outline, simple outline as well, as we did previously, and then you can either remove it, or you can change the color to visualize it properly. So these are my slope units, right? All right, so the now another step is to prepare these three maps, which is about slope, aspect, precipitation, and NDVI. Sorry, four maps. These are the variable map which might impact the landslide. So in order to prepare those, we are going to use the dam and also our slope unit. And for the simplicity, so we are going to use the Google Earth Engine. So simply for assessing the Google Earth Engine, simply type code.earthengine.google.com and then log in or sign up if you don't have any account. And for this particular section, I'm also referring to the TT's original repository, which is SRT plugin, and here I found it interesting. So using this plugin, we can simply calculate the temperature, precipitation, NDVI, and also dam. So simply in order to like calculate compute these, I'm going to use this plugin. But I found one problem with the main.js file, which was updated 2 years ago. That's why I simply copy that function. So simply click here and then copy the whole text, copy the raw file, and then paste it, create this same function and then paste it here. All right, so I also like created the file over here and then simply copy and paste that code over here. And here simply based on whatever the error you encounter after running this cell, you need to manually debug and then try to solve it. But for now, till this date, this code is perfectly working fine. So don't worry about these two functions. I'll provide the link in the description below, video description as well. But as I said before, so the code is inspired from this repository, which is from TT himself. And okay, so here basically what is happening is it's also using the another library called TAGEE. And then here they are like simply computing slope somewhere here, and then also all the required things whatever we need. Simply if you run this cell, so you will get nothing, because this is just the function, right? And then we need to test this, we need to call this function, and then we need to download our data set. So simply I don't need this one, so let me save again. And here before like running this code, so you might also need to add an asset. So here in the asset tab, create the new and save file. All right, here you need to upload the shape file, which is slope unit, which is inside landslide susceptibility intermediate output, right? And then you need to select these, and then simply select, like you can write AOI or the area of interest. For me, it's this, and then simply write whatever name you have and then simply upload it. It might take few minutes to upload it. So I already uploaded, so I'm not going to upload it again. And then you need to move it over here in the code cell using this button, import button, and simply change this to map unit, right? And then delete the above one. Oh sorry, it should be okay. The thing is maybe I'll write am only, and then simply first delete the previous cell, or simply copy this name because I'm getting the same name error, and then paste it over here, right? So it's map unit, right? And now the only step you need to do is you need to import your code. Maybe I believe you can use my code. I'll make this repository public, and after that you simply run this cell. So it will call the SRT plugin from TT. Right now it's stored inside my local plugin directory. And then here in the geomorphology section, we are simply downloading the slope map. And then this is the precipitation one. In order to download the precipitation data, you just need to call SRT precipitation and then provide the map unit, and then from when to when you want to download, and simply it will take the median value. And yeah, and then the scale of map, right? This is 500 meter resolution, I believe. Okay, so after that also we are computing NDVI using SRT plugin. NDVI from 2011 to 2022. This 100 represent the map scale, right? And here in the display we are simply like displaying our map below, and then we are preparing NDVI geomorphology, which is slope mean, and then the precipitation map. And if you check here, you can toggle on and off these things to find out your result. For example, if I'm only interested in units, then these are my units. It's similar to in QGIS, right? And then this is my NDVI mean. So it might take some time to compute actually. So here, this print statement, it's still computing, right? But in the tax statement, you will get tax to like run the sales. So simply run it, and then it will. I'm not going to run right now because I already saved this in the Google Drive. So simply run it, and you will get the folder SZSRTS Lanka, which is my output directory. Feel free to write any name you want, and inside which you will get all the these parameter maps. So yeah, this export to drive a function we are calling here, it will help us to like save our outputs to the Google Drive. All right, so if you run these things from here, so you will get the output in the Google Drive. So for me, it's sjsrts Lanka, and then here I'm going to select all the files, for example here, and then maybe I'll download it. So these all are my intermediate output. So in order to get these maps, you only need to write this code. Don't worry about it, I'll provide in the video description. And then so far the my username it's working, but in case if it doesn't work for you, so you need to manually adjust that script or whatever I show you in here, right? All right, so now it's downloaded. I'll move this folder to the intermediate output. This is the downloaded directory, I mean downloaded parameters, right? And here are my maps, right? So let me load these maps in QGIS. We just need a .ssp file and then import it inside QGIS. Okay, so these are the NDVI value, precipitation value, and geomorphology value. So if I say in the geomorphology attribute table, so simply it's saving our elevation mean, aspect mean, relief, and SS. I think there are lots of things going on. And then this DN value, which is similar to our slope unit value from our slope unit polygon. And we just need to like select few of the parameter, not all, right? And here in the similarly in the precipitation, so we'll also get the similar attribute table. So these all parameter related to precipitation, median, sum, maximum value, minimum value in our area of interest, right? And then this NDVI also, this is also like similar to other two. So we have NDVI mean and NDVI standard deviation, and also of course we have DN value. And so yeah, in next step we are going to merge these three parameters in the slope unit and then prepare one single map containing like all the variables. All right, so let's join the table using this slope unit button. And here now I need to like select the join, and then using this plus button I can join the tables. So I'm going to join these three one by one, right? First of all, let me join the geomorphology one, and then join field will be of course DN, which is common in my target, and then the input variable. And here in the joining field, actually I'm interested in few of the parameters, so maybe I need to select this one. I'm interested in elevation, aspect, and then the slope mean, right? Other parameters feel free to add if you think those will affect the landslide. Otherwise, yeah, just leave it as it is. And here in the custom field name prefix, I'm going to remove and then simply hit enter. So now if click OK for now, and for now if you like open the attribute table, you will see these three fields from another table, which is geomorphology B table, um, attaching in slope unit, right? And similarly we can join other tables to other shape files too. For now I'm going with ndvi, and then of course the common field is dn, and then joining field will be ndvi mean, and then custom field name nothing. Okay, now join the other table, which is precipitation, and for the precipitation this joining field will be dn, but in the joining field we have rn max mean value, and then the costume field name will be none. And then I hope I join all three, right? And then click OK. So now if you see the attribute table, so all the like parameters whatever we need to compute the landslide susceptibility map are added in the single shape file, right? So now the another step is to simply export these. So I'm going to export and save this feature as shape file, and it should be saved in the location desktop landslide susceptibility final map, and then I'll say su final. Okay, so this is the name, and then coordinate system, feel free to select one with your CRS. For me it's UTM zone 44, so I'll just click OK. So now if I see the attribute table of newly created shape file, so these all fields are now permanent with this one, right? So the another step is to see whether there are null values or not. So basically I'm going to rearrange those and then see. So here you are seeing some of the null values, right? These are due to the resolution of our rainfall, I mean the precipitation one. And then if you select one of these are actually the small slope units, I believe. Let me toggle off this one, and then let's see, or maybe we can select this few. Okay, so you are seeing that these are the very small slope units hiding somewhere. I'm not seeing all the slope units or whatever I selected, but the main thing is these are very small slope unit, and due to the resolution there are still few null values, right? We are going to remove those null values. So in order to remove those null values, you need to open the attribute table here, and then maybe unselect the things. So unselect, sorry, I need to go to attribute table, which is over here, right? 0 selected, and now I need to edit it, and then compute the, go to field calculator, open the field calculator, and then you can assign those value, right? And here I'm going to say update existing field, and then which is rn max, and here I'm going to write my condition, right? So if my column name, which is rn max mean is null, then I'll manually assign the value to the 72, which is average of almost this whole study area, and otherwise I'll say it is rn max mean, same as it is, right? So basically this expression is saying that if my value is rn max is null, then it will set the value to 72, otherwise it will be rn max.mean. So simply click OK. Now you will get all the like values over here, right? And now you need to save it and then toggle off the edit button. So now we don't have any rn max value no more, right? All right, so the now another step is to merge these landslide points into these polygons. So in order to do that, so simply we are going to data management and then join attribute by location, and for the input join to feature in, we select this our final map, and then make sure to select intersect, and then the intersect with ls, which is landslide inventory points, right? And here we are merging this one to one. That means if it intersect with one polygon, then can't be intersect with another one because it's point inside polygon, right? So simply run it, and after that you will get the join layer. And then if you see the attribute table, now this ls landslide inventory is already joined. You can see the id here, right? And then this null will represent we don't have any intersection between these polygons. For example, let's select the one, and yeah, looks like it's intersected with the this point, right? And then similarly these all first few points are intersected, which is up to 34 points we have like intersection, right? And now the in the step is to like simply change the this id into whether it's landslide or not, right? So in order to do that, so simply click edit and then open the field calculator, and then in the field calculator we are going to create the another field named as ls, whether it's landslide or not, and then it should be whole number. And here we are going to write the condition. Here the condition will be if our like the id, which is this field, so simply this field, if id is null, then we put it as 0, otherwise it's as 1. So that means if the id is something, then it's the slope unit that has landslide, otherwise it doesn't have landslide, right? And then simply apply and then click. Yeah, so now we got the if there is id, then we got 1, and then if there is null value we got 0, right? So now the we just need to save this. We need to save this layer as a permanent, make it permanent, right? So in order to do that, we are going to export it as a zip file, and maybe I'll write v2. So this will be our final version, and then save it, right? So now if I see the attribute table, so we have all the required field, right? Maybe the id field we don't need this, so we can edit it and then maybe delete, and now delete the column with id, right? This is no longer needed, right? So yeah, so now save it and then toggle off the edit mode. So this is our final map. So here if you want to style it based on like different variables, for example, if you want to style it based on like or maybe the graduate color based on like the ndvi value, you can see the ndvi mean like this. So where is it? Looks like it's not working. Okay, let me go to the property again. Sorry, I forgot to classify it, and then apply. Okay, so this is my ndvi mean value, right? Similarly, you can visualize based on any of the property. Now our data set is ready. All right, so the final step is to compute the landslide susceptibility map using logistic regression or any of the supervised machine learning technique. So in order to do that, we can simply search for SZ plugin in the our toolbox, and we can use the k-fold cross validation section. So here I'm going to use the logistic regression for me, but feel free to use any of these algorithm. It should provide the similar result. And here maybe I can say my final map, and then my dependent variable first select all. Since dn is just the idea of those slope unit, that's not the dependent variable, and the ls is the actual whether landslide happen on that slope unit or not. So I can simply toggle it off since it's the dependent variable, right? And for the dependent variable, we can say the target variable, which is landslide. And then for the cross validation, you can set whatever number you want. For me, first of all, let me try up to 1 k-fold cross validation. And for the directory, output folder directory, so maybe I can say 3 final result, and then hit run. So basically now we are getting the we got the like temporary file. And here if I open the attribute table, I got this si value, right? This si means it's the slope unit susceptibility value. So based on these, I think we can prepare the susceptibility map. So simply go to attribute, sorry, not the attribute table, simply open the properties, and then instead of simple fill, I'll say graduate color based on si, and then maybe change the color ramp to maybe red to blue, I mean blue to red, and then classify based on natural break, which look nicer. So here what this value represent is red value of the slope unit represent those slope unit has higher chance to failure having landslide. And then this blue region represent the slope unit that has almost like that are almost in stable condition. And yeah, this is my final landslide susceptibility map. And if you want to check the learning like process, what are the ratio of false positive and true positive rate. So this is my roc curve, right, based on like only one fold of data. And my auc score is 0.71. It's not that great, but it's quite good. So similarly you can like use the uh, multiple k-fold cross validations to figure out how it looks like. So for that, simply you need to select you need to repeat the same process as I show you previously. So ls, and then in the k-fold cb you can provide 10 or whatever number you want, and then say saving directory is 3 and hit run. All right, so this process executed within 2 seconds, which is quite fast. And here in this new file as well, we are seeing the same si values. So, and if you want to check the roc curve again, so it will now look like this. So based on different fold, we have different accuracy. And if you want to see the equation, we don't convert. And then these are my intercept value, elevation, aspect, slope, and ndvi, and rn max. These are the values, these are the like weight of each parameters to determine whether the slope unit is landslide or not. Based on these parameter you can guess like slope unit has the higher values, that means slope unit, I mean the slope value will mostly affect the landslide to determine whether the area is more prone to landslide or not, and other are little bit less compared to slope mean. All right, so yeah, that's all about landslide susceptibility mapping. I hope you enjoyed this video, and if you enjoyed this, hit the like button and subscribe to my channel. Thank you for watching.